Welcome everyone to the All Hazards Consortium educational webinar series. Today we're going to look at a project being conducted in the National Capital Region focused on video camera integration. Over the last several weeks, the consortium has been involved in several meetings and discussions around this topic of integrating video cameras on a number of fronts, particularly in the rail community. Last week, a number of rails met in Philadelphia with several states to look at common rail initiatives and projects they could undertake together, both private sector and state and local government. And integrating rail video systems was high on the list. Today we'd like to welcome John Contestable. John has been one of the founders of the All Hazards Consortium, was formerly with the State of Maryland Department of Transportation for many years, stepped down from that job and moved into the higher ed arena, working for Johns Hopkins Applied Physics Lab. I'll let John explain a little bit his background. So with that, let me introduce Mr. John Contestable. John?
Appreciate the opportunity to talk about this project. As you said, when I was with the State of Maryland, one of my last assignments was as the statewide Interoperable Communications Coordinator, or the SWIC as they are called. And we looked at video integration in the state of Maryland, and with that kind of background, when I came to Johns Hopkins University Applied Physics Lab, we were able to work with the National Capital Region under a UASI grant to look at integrating video across the National Capital Region. For those that are not familiar, the National Capital Region is the District of Columbia and the surrounding counties and municipalities in Maryland and Virginia. And it's a challenge because video systems are not terribly interoperable, and on top of that you have different jurisdictional arrangements and agencies involved. So it's a multi-jurisdiction, multi-agency, different technological platforms. Trying to get them all together on the same page is a real challenge. There's a number of other places across the country who are doing this kind of work right now, integrating video systems, but when I've looked at those projects, they tend to be single jurisdictions integrating multiple agencies, or they tend to be the same technological platform that everyone decided to use. And so this project is challenging and a little different in the sense that it's multiple jurisdiction and multiple technology platforms for video. So we're going to walk through some slides, and I'm going to go through some of them rather quickly because we have quite a few to get through. Okay? The next slide shows the agenda for today. We want to talk a little bit about the nature of the video sharing problem, talk a little bit about the team that has been put together to address this, some of our accomplishments, the conceptual model for looking at interoperability in general, and then how we've applied it in the National Capital Region. Some of the video sharing ground rules, a 2B architecture, as well as a 2B security concept, and some recommendations and next steps. The nature of the video sharing problem on the next slide outlines some of the issues that make sharing video images with other entities such a problem. Typically, there's no policy or concept of operations for sharing. There's issues with video ownership and permissions. The ability to control a camera can be problematic both technologically as well as from a policy standpoint. There's no common networks to move these images around. There's varying formats and bandwidth and file sizes. And some of these systems, if you have too many users that access a camera, it will crash the system. And most of the systems are designed to aggregate video into one location, not so much to share it or distribute it to other folk outside the agency. So these are the reasons you can't easily share video across agencies and jurisdictions. As far as an overview of the project, here's the goals and the critical success factors. We want to achieve interoperability, develop a ConOps, develop a strategic direction for future investments. You see down the bottom, the phase 1 study was to investigate the problem and recommend a way forward, which has been completed as of March. And phase 2, which is what we're involved in now, is to demonstrate the architecture that we've proposed amongst the regional departments of transportation. And in this region, that'll be Virginia DOT, District of Columbia DOT, and Maryland State Highway Administration. On the next slide, you'll see who some of the project sponsors, managers, and partners are. The National Capital Region Critical Infrastructure Protection Working Group was our sponsor. Josh Jack from DC Homeland Security and Emergency Management Agency was the project manager, and of course myself from Johns Hopkins University Applied Physics Lab, and the Skyline Network engineers and their subsidiary, Earth Security Electronics, were our subcontractors on this project. If you were to look at the statement of work, we basically had 5 tasks. We wanted to conceptualize or finalize the conceptual project plan, conduct a video systems inventory to see what kind of cameras and systems are out there, analyze that video in task 3 to determine any coverage gaps and some rough order of magnitude costs to migrate to an interoperable platform, develop a concept of operations under task 4, and lastly, we have an optional task to do additional systems integration. As for study participants, you can see that we had quite a few. Some of these partners were a little more active than others, but these are in fact all the parties that we either met with or participated in some way in the study. And we've got quite a range from some police agencies to DOTs to airport authorities to federal agencies. You see the National Park Police, U.S. Park Police, to regional authorities. You'll see Washington Metro on there. So we have quite a group. The group down the bottom with the asterisk indicate that they're video consumers, not necessarily generators of video, but would want to be part of any solution. So those are the folks that we've met with over the course of this study. As to study accomplishments, we developed an inventory of the various participating agencies and produced a concept of operations. That concept of operations was developed by meeting with various users from these agencies to understand what they wanted out of the system. We developed a GIS map-based display of cameras, where they are and what their footprint is. We have a as-is and to-be architecture we're going to go over, and a security framework, as well as some cost estimates for the to-be architecture. I want to talk a little bit about the conceptual interoperability model. As we were going to analyze the video world, we had to have a framework against which to understand how these systems could talk to one another. And this conceptual interoperability model actually is addressing more than just video, but it provides the backdrop for the framework under which we're going to propose solutions for the video world. And basically what it says is, imagine, if you will, 3 layers. And these layers would be the data layer, which is at the bottom of this graphic, the integration layer, which is in the middle, and the presentation layer, which is at the top. And what it says is that there's various data sets in the data layer, and they're shown in different colors. The local data sets, regional data sets, state data sets, and national data sets. Those circles with the L and the R, the S and N. And one way to achieve interoperability across these data sets, and by the way, these data sets could be video systems, could be GIS applications, they could be critical incident management software tools like a WebEOC or an E-Team. Doesn't really matter. What it is are disparate applications and systems housed and owned by different agencies at different jurisdictional levels. And one way to achieve interoperability would be to connect these systems directly. So you could connect a local data set to a regional data set to a state data set and so on. You're poking a lot of holes through your firewall to build custom one-off solutions between these legacy systems in your agency and in the next agency. And so it's not a particularly good way to achieve interoperability at the data layer. Rather, this construct shows that those data sets should publish once into a middle layer we're calling the integration layer. So that if I want to see, if I'm at the state layer and I want to see a local video camera, rather than connecting directly to the local system, you connect to a tool in the integration layer that would show that information. So as an entity in the data layer wants to participate and see video from across the region, they wouldn't look to their peers in the data layer. They would actually look at a tool in the integration layer. In the integration layer, you have to have a bunch of applications or services and web services or hardware that provides the ability to ingest and aggregate whatever information you're talking about. Those tools would probably address the four questions that are posed in the integration layer. Those questions are, where is it? What do we know about it? Can we talk about it? And can we see it? Well, the video question addresses the video application in the integration layer addresses the fourth question, can we see it? Where is it? Is all about GIS, so there needs to be some integration layer tool that has a GIS component. Can we talk about it in a digital world as a SIM software, so that your ability to have chat or message boards or incident logs would come from a SIM software. And lastly, what do you know about it would be sensor information, be it weather or flood gauges or something like that. So you need a suite of tools in the integration layer that would be able to aggregate information that's of that nature, as well as share it across those different tools in the integration layer. And that, of course, has to be done respecting network protocol security and standards at the bottom of that layer. But you're not done. Now that you've aggregated information, you now can see it and visualize it, and you can visualize it in context with the other information from those other applications, those other tools. But you need to overlay some decision support software or some analysis tools so that you can extract out what's important to look at. So you would do that, and based on those rules and those protocols and those concepts of operations, you would then be able to push out to the presentation layer what information is important to surface. And that information would be presented in that presentation layer across a various number of platforms, from telephony with reverse 911 or 511 applications, to a short message service, or to a multimedia message, or to a web page, or to a portal. And so a video clip, let's walk through this example. You have a localized video camera that would publish to the integration layer video tool so that state, regional, and national components could take a look at that and see the local video. And the video, selected video, could be pushed as an MMS message and in fact could be posted in YouTube to a channel, quote unquote. So if you're an emergency management agency, you may have a YouTube page that has video that you can post there that could come through this type of a system. So to summarize, you want to be able to aggregate data and then integrate that data so as to achieve interoperability in the integration layer. And you want to be able to push that information out via a number of different channels to different users through different methods in the presentation layer. That's the conceptual model.